All right. Thank you, everyone, for coming to the last water talk of the season 2024-2025. My name is Luis, and I'm the co-chair with Harriet here, the co-chair of the Geo AquaWatch Early Career Societies. So I will give a little bit of the introduction about the society and then um, about our speaker today. So as you know that we have AquaWatch is an initiative under the Geo Group and with the focus on developing and building the global capacity and utility of Earth observation derived water quality data products and information to support water resources management and decision making. And under that, we have the Geo AquaWatch Early Career Society. So we established it in 2022. So we have the responsibility for initiative effort to attract and empower and engage early career scientists. So we currently have activities such as the water talk theory. We also have career planning and mentoring. So this water talk theory is actually a series of webinar that we share experience and knowledge about water remote sensing research and application from early career scientists. So this program is actually designed to support early career scientists from underrepresented group. We try to provide mentoring skill and communication skill by all of the volunteer from our societies and from senior researcher. Um, so today we have Sergio Cárdenas. Um, he's a geoscience researcher and a PhD candidate from the Federal University of Rio Grande do Sul. So he researched on coastal and marine processes using remote sensing at the Center for Coastal and Oceanic Geology Studies. So he possesses expertise in geospatial data management and Earth observation tool and environmental geology. So his current research is focused on sedimentation transport and from in coastal environment and as well as the effect of human activities and climate change on these processes. And today, Sergio's talk will be about assessing southern Brazil extreme rainfall effects on sediment transport and water quality on the worst chocked lagoon. So the floor is all Sergio.
Thank you, Doi, for your very good introduction about myself. And yeah, as he mentioned, I will present to you our remote sensing monitoring approaches that we are carrying out right now at the Federal University of Rio Grande do Sul for the world's largest chocked lagoon. Just to give you some insights about the image that you are seeing in this first slide. Oh, I forgot to ask, can you confirm if you are watching my presentation?
Yes. And also one reminding is if you have any question, yet also a chat tool that you could put that in the chat, or you could wait until the the finish of the presentation, and we have also have the discussion section later on.
Okay.
And just one thing I'll add is that it's being recorded, so just be aware of that. Thank
Yeah.
you. And it will be put on our YouTube channel later, so.
Okay. Thank you, Doit. Thank you, Harriet, again. Just to take back from when I left, the image that you're currently seeing is in the study area that we are working right now, located in southern Brazil. I want to call your attention to the brownish tones of the water that you can see here, and it is because this field campaign was carried out during the extreme rainfall events in southern Brazil of 2023, which is going to be the main subject of today's presentation. Uh, Well, so to start, I will speak about a bit of our study area. The Patos Lagoon is the largest water body in South America and the world's largest chocked lagoon, following the XGRF classification for coastal lagoon proposed in 1986. It occurs in the southernmost region of Brazil, particularly in the Rio Grande do Sul state, and is part of the Patos Marine Lagoonal System, a lagoon barrier complex on the coast plains of Brazil and Uruguay. Well, a special feature of these lagoons that you may know to understand a bit of our results in the further slides is that unlike other Colson's lagoons worldwide, the Patos Lagoon receives water directly from large rivers that comprise a total catchment area from the watershed of around 200,000 square kilometers. That you can see the very big size of the catchment area of the Patos Lagoon, highlighted here in greenish tones. Especially the Guaiba hydrographic region and the Guaiba River here is this feature in the northern section of the lagoon. Is responsible for the 85% of the water that comes from rainfall or of the fluvial discharge that gets into the lagoon body. Well, another special feature of this lagoon is that the only way out of this water to the Atlantic Ocean is a single narrow inlet located in the southernmost part of the lagoon. It is called the Rio Grande Channel, which is an estuarine area of the lagoon with a microtidal regime and a median tidal amplitude of 0.26 meters. Well, another feature is that it is a shallow, vast system. It is vast because it is 250 kilometers long and is partially segmented by sandy banks into 4 cellular lagoonal cells. And every cell has approximately 50 kilometers wide. So it is a very big water body. However, its bathymetric depths do not exceed the 7 meters. So as you can see in this map of the bathymetry of the region, and thus it is shows a very huge water body, but it is very shallow. The importance or the aquatic relevance of these water bodies, both the Guaiba River and the Patos Lagoons, is the ecosystem services they provide to the 17 municipalities and the communities associated to those municipalities that surround the water bodies. For example, the Guaiba River, which is a freshwater body, has 5 water catchment points that supply fresh water to the Porto Alegre metropolitan region and thus to more than 4 million people. The map showing the location of those catchment points is up here. And talking about the Patos Lagoon, its unique morphology as a barrier lagoon chocked system, which isolates the water body from the ocean, its high river discharge, and its microtidal regime, makes the Patos Lagoon experience low salinity conditions in most of its lagoonal areas year-round. So those low salinity conditions makes its water suitable, and it's actually being used for irrigation of croplands surrounding the lagoon, especially rice croplands. And we have another ecosystem services that are very important for communities surrounding the lagoon, as it is fishing, which involves thousands of artisanal fishers or even industrial fishing. Maritime transport is another important ecosystem service from which we have very important ports in southern Brazil, as it is the Rio Grande, Pelotas, Porto Alegre, and Guaiba ports, which facilitates international and national commerce as well as transportation. And we have other ecosystem services such as nursery habitats for aquatic species, nutrient cycling, and regulation of carbon cycles. Well, talking a bit about the weather, and it is important because it's key to understand why we experienced extreme rainfall events in this region of the world. Is that we are in a warm temperate region with a confluence of atmospheric factors, such as a frequent passage of cold fronts coming from Antarctica or southern Argentina, baroclinic trucks, low pressure systems, upper level cyclonic vortices that create an unable, dynamic, unstable weather in the lagoonal region. We also have moisture corridors originating in the Amazon and the Atlantic Ocean that brings a lot of humidity from the northern South America to the southern region of South America, and it is facilitated by the South American low-level jet, which is this humidity corridor pointed here as a red arrow. And when this hot, humid matter air finds with these cold fronts, they produce naturally high rainfall. Climate change effects have altered the natural balance of the weather conditions in the study area, causing heavier rain during climatic variability phenomena such as El Nino, which we experienced during 2023 and 2024. And as you may notice, this is a figure showing how the rainfall occurs due to the cold fronts, but it is highly enhanced by climate change effects. So these alterations by climate change triggered the extreme rainfall events that we witnessed during 2023 and 2024 in southern Brazil. And these extreme events severely impact the regions surrounding the Patos Lagoon and the Guaíba River. It is key to understand that the two events, although they have similar causes, they have some differences that are important to point so that we better understand the results of our research. The 2023 event was characterized by two pulses of heavy rain, one in September of 2023 and the other one in November of 2023. Well, the causes of the extreme event are listed here. As I mentioned before, a stationary frontal system, we have an upper level low pressure area, and the 2023-2024 El Nino. And we can see the effects or the extension of the floods in the Guaíba hydrographic region, which I showed in the study area slide. The flood regions were very, very high, and the effects for the population inland was devastating. The 2024 event had similar characteristics. However, we had a worsening of the rainfall conditions due to this abnormal static heat wave in central Brazil with very high temperatures that limited the migration of consecutive cold fronts and a bringing of humidity both from the Amazonian region, the Atlantic Ocean, and the Pacific Ocean. This caused the worst flooding event in Brazil history, and it can be noticed even in the Patos Lagoon, which, as you saw in the first slides, is a very huge water body, but the amount of water that came from fluvial discharge during these events were enough to rise up the level of the water in the lagoon, as you may notice in this map. And this is a photograph of the city where I live, in which you can notice the devastation caused by these floods. Well, something important to point that I forgot is that in 2024 only had a single pulse of heavy rainfall, which is a key difference with the 2023 event. The efforts for mitigation of these extreme rainfall and flooding events in the region are focused mainly in the inland and continental region. So the objective of this study is to perform an assessment or evaluation of the impacts in the water quality and suspended particulate matter dynamics, both for the Guaiba River and the Patos Lagoon during these extreme rainfall events. Well, to achieve that objective, we designed this flowchart, which summarizes our methodology. The first step was to download our satellite dataset. We based this study mainly in remote sensing products due to the lack of permanent monitoring stations for water quality, neither in the Guaiba River nor in the Patos Lagoon. So we had to rely on remote sensing to perform this study. And due to the high cloud cover that characterizes the region, and especially during these extreme rainfall events, we had to use a daily sensor such as Sentinel-3. And the reason why we choose it is because it has a better signal to noise performance and spatial resolution that, although it is coarse, it is around 300 meters, it is good enough for such a very big water body as it is the Patos Lagoon. We have also a good spectral resolution, and we conform Sentinel-3 Olchi level 1 dataset to perform this analysis. Well, the pre-processing and atmospheric correction was carried out through the Accolade software. And then we use the multi-wavelength suspended particulate matter algorithm with IOP calibration to estimate the amount of suspended sediment before, during, and after the event. The suspended sediment data was validated with in situ water sampling, which was very challenging. I will explain it more in detail in the following slides. But we also utilize another water quality parameters to get a better assessment of what happened with the water body during these extreme events. And we used a chlorophyll alpha analysis ready product from the Sentinel-3 Olchi level 2 ocean data, which is derived from a neural network. I will explain it a bit more in detail in the future. And we calculated the turbidity using the NetCat 2009 near infrared algorithm because it performed well in another studies for the Patos Lagoon. Well, we also made a mapping of the sediment plumes formed during the events, and we calculated the plumes, the sediment plumes depth and plumes mass using the euphotic depth. And finally, we joined together all of this data to perform analysis of SPM dynamics and water quality changes during the 2023 and 2024 extreme rainfall events. So the logic that we were following for this analysis was how were the conditions of the lagoon before, during, and after the extreme events. So before the 2023 pulses of high rainfall or with heavy fluvial discharge, we have a turbidity and with normal low values, natural low values for the lagoon, which was heavily increased after the September of 2023 event, and that was even more increased during the November of 2023 event. Here you can see the formula of the turbidity proposed by NECAT that, as I mentioned before, it was already proven to have a good performance in the study area. Well, for the 2024 event, we see that by March of 2024, the lagoon is reaching its natural low turbidity levels. It is a recovery in a low time period, but then came the heavy fluvial discharge of 2024. And with this, we reached the highest turbidity values, which is around 450 FNU. And by the end of the study period, which is August of 2024, we see that the levels of turbidity are still a bit high. To summarize better, we took all the images from the study period, which is June of 2023 to August of 2024. We took all the images that allowed us to evaluate at least the 85% of coverage of the lagoonal water body, so that we can get a good overview of what was happening in the lagoon. Then we summarized all the pixels inside the lagoonal water body and the Guaiba River in a turbidity median, which is the line that you can see here, the brownish line. And the grayish regions represent the variability of the turbidity concentrations in the interquartile range from the 25th percentile to the 75th percentile. So it is very clear how the high fluvial discharge is increasing the turbidity in 2023, reaching very high median levels and a higher variability when we have the fluvial discharge. And although the 2024 event consequences inland were worse, it seems that the median turbidity for the lagoon was a bit lower compared to the 2023. It is because, as I mentioned before, the 2023 was a heavy rainfall during a long period of time with two pulses of high fluvial discharge. And in 2024, we had a single pulse of heavy rainfall. However, even though it reached very high levels for the lagoon, and by the end of the study, it haven't reached the pre-flooding turbidity levels. Well, our chlorophyll alpha results are more like anecdotal results, because we don't have any sort of validation of the levels of photosynthetical activity shown here. However, these are derived from a neural network algorithm for optically complex water, such as coastal and inland regions, where water constituents like sedum or suspended sediments influence the optical properties. And it is based on the Case2 regional coast color processor, which was originally developed for Mauricio and adapted for Olch. It is a feed-forward neural network trained on a comprehensive dataset of simulated and in situ measurements that represent a wide range of water conditions worldwide. So this is an analysis-ready product, what I'm showing here, and it can give us some insights about what happened with the photosynthetical activity, not especially in some regions. We use it here the same logic as in the turbidity, before, during, and after the events. And as you may notice, in some particular, we have a general increase in chlorophyll activity. These images correspond to low turbidity levels, so that a very high concentration of sediments do not interfere in the signal to give a better overview of what is happening with chlorophyll alpha concentrations. And we have a high increase in chlorophyll concentrations in some particular regions of the lagoon, as it is the Lagoa de Casamento or the Rio Grande estuary. This is repeated in the 2024 event. So the Lagoa de Casamento also reaching very high levels of photosynthetical activity, even in August of 2024. and it is probably due to the very high input of nutrients and the calm conditions that followed the extreme rainfall events, which are very good for algal to bloom. So for the SPM, we performed some water sampling for validations. However, we had a lot of constraints in terms of the spatial distribution of the points for used for validation. This is because we tried to adapt our suspended particulate matter algorithm to the extreme conditions that was facing the lagoon. However, during these conditions, a very high amount of water and sediment was put into the system. And as you notice in the second slide that I presented, the bathymetry is very low. So due to this very high input of sediment, the navigation challenges were all messed. And also we have some very dangerous conditions for embarkation. So basically, large boats couldn't navigate during these periods, and we have to go through small boats. But most of the small boats were used for rescue efforts of people and animals that were suffering during these flooding events. That's why our water sampling were limited only to the regions close to our city, which is Porto Alegre. It's located here. But it was also an effort from us to try to validate. This field in situ water sampling campaigns were carried out during 2022, 2023, and 2024. The 2022 campaign was used to create a contrast between conditions of calm water in the system and high fluvial discharge for the extreme rainfall events. We used in situ water sampling and filtering to evaluate and calculate the amount of suspended sediment in the first measure of the water column. Well, to evaluate the suspended particulate matter concentrations, we used a multi-wavelength algorithm, as I mentioned before, which is designed to improve SPM estimations for optically complex waters. And it obtains a solutions for a range of possible combinations of IOPs, or inherent optical properties, and mass-specific coefficients within an observed range of variability. To make it simple, it allows to evaluate various situations or combinations of IOPs and mass-specific coefficients. And then we can get an uncertainty estimation from that, which is very good for this type of analysis in which we don't have a lot of in situ data. We have to discard some of the old bands to perform this analysis, for example, below 630 nanometers, because of the interference of dissolved organic matter, between 670 to 700 due to the chlorophyll absorption peaks, and between 700 to 800 nanometers, because our empirical test showed that the 700 nanometers bands were showing issues, especially in the high turbid plumes of 2024. So we had to stay only with these two bands to perform the calculations of SPM concentration. And this is basically the workflow to adjust the IOP combinations to get better results compared to the in situ data. Well, the SPM concentration in Patos Lagoon follows a similar behavior to the what we show in turbidity. During 2023, we reached maximum values around 200 grams per cubic meter, being worse during the November 2023 rainfall fluvial discharge poles. And in 2024, we have seen a very high contrast between calm conditions of the lagoon and the very dense sediment plumes that entered into it due to the 2024 flooding events, reaching up to 380, almost doubling the maximum values compared to the 2023 event. We see also almost a linear relationship between suspended particulate matter and turbidity, with increases in the median levels of SPM concentrations during the 2023 pulses, and with higher median values compared to the 2024 event. However, the variability here in the interquartile range is much higher due to the high contrast of the very dense plumes entering into the count waters of the Patos Lagoon. Here are the results of our validation. We have an squared R of 0.628, which was reasonable for the type of study that we are conducting and the means of validation that we use. And finally, to perform an overview of the sediment plumes formed in the lagoon during the extreme events, we used the plumes algorithm, which is especially explicit and semi-supervised approach. It is we found it fair for this study because it represented it gives a uniqueness to every sediment plume that it is analyzing, and do not encloses or is not limited to a single threshold like it is used in other type of analysis. Well, from this algorithm, you can get both distal and proximal plumes, but only the distal plumes were giving a good result. And here we have a plume area graph of all the plumes that could be mapped for the 2023 event. But this graph might be confusing, since most of these plumes do not correspond actually to the rainfall event, but they are within this 2D period, because in August was still a month of analysis to get some insights of what happened to the lagoon before the rainfall events. So we have here a lot of plumes that could be mapped before the extreme events, and we only have 2 plumes that could be directly related to the extreme rainfall event. One mapped during September of 2023, which is the largest in terms of area, reaching up to more values than 2,000 square kilometers, is this one here. During 2024, we had better conditions to perform plume mapping, which allowed us to construct the history of the sediment plume entering into the lagunal body, and how the plume was expanding until reaching around 3,000 square kilometers of area, and then started to dissolve and reduce its area. Here you can see it graphically, how the sediment plume is growing, and then it starts to dissolve. We tried to perform an analysis to relate the fluvial discharge with the plumes area. The fluvial discharge, for the fluvial discharge, we do not have fluviometric station in the Guaiba River. However, we construct some sort of the estimated fluvial discharge from its main tributaries. But during 2023, we were only able to relate this point here with the high fluvial discharge coming from the Guaiba. All of this period of high rainfall could not be related with large sediment plumes because of the lack of suitable images of this period. During the 2024 event, it was so devastating that it took away all the fluvial stations that I mentioned before, so we were not able to perform the same fluvial discharge analysis. However, there was a station measuring the water level in the Guaiba River, which is directly related to its fluvial discharge. And here we can see a correct relationship and a space delay between the water reaching the Guaiba River and the sediment plume starting to grow and being noticed by the Sentinel-3 satellites. Just to give you some comparison with the other event, some researchers were able to relate this 5 meters above the regular level of the Guaiba River were related with around 30,000 cubic meters of fluvial discharge per second. Well, finally, to calculate the plume mass, since we didn't have any data of how was the hydrodynamics of the sediment plumes during this event in the Patos Lagoon, we only had data for the Guaiba River, but the Guaiba River has a totally different hydrodynamics compared to the Patos Lagoon, so it cannot be extrapolated to that region. And then we used some assumptions to estimate the plume mass using the aphotic depth. So due to the turbulence in the water caused by these extreme events, we are assuming that the vertical mixing, especially in this type of shallow coastal areas, we can have the same concentration along or uniformity along the water column, at least in the aphotic depth. So to calculate the aphotic depth, we use the diffuse attenuation coefficient, which was derived also from the Sentinel-3 Olchi satellite. Finally, using the formula derived by proposed by Kirk and modified by Tang in 2007, we analyzed the aphotic depth and multiplied it by the pixel area to get the sediment plume mass. This plume mass was compared against the plume area. As expected, we have a linear relationship. The larger the sediment plume, the more dense and more sediment mass that it carries. And as you may notice here, the 2024 sediment plumes are highlighted in red and the 2023 in blue. And we have that the 2023 event were larger and with a higher mass, reaching up to 5 million tons of sediment that they could be carrying. And this has some hard implications for the aquatic ecosystems. Well, or to conclude, our final considerations are the following. The turbidity in the Patos Lagoon and the Guaiba River reached its highest median levels during the 2023 extreme rainfall event. As I explained before, it was due to the high rainfall during a long period, prolonged period of time, in contrast to 2024, which was a single pulse. And the turbidity of the water bodies has not returned to pre-flooding levels even by the end of this study, which is August of 2024. And the chlorophyll alpha levels indicated an increased photosynthetical activity, particularly in the lagoon estuary and the Lagoa do Casamento. The extreme rainfall events represented unprecedented input of suspended particulate matter into the water bodies. And although average turbidity was higher in 2023 event, the 2024 generated the most extensive sediment plumes, as we saw in the previous graphs. The sediment plumes formed in 2024 might have contained as much as 5 million tons of particulate matter or of sediment, which surely changed the bathymetry and thus modified the navigation channels, reducing or degrading the ecosystem services provided by the lagoon. And this is the first study in the lagoon, Patos Lagoon and Guayba River, assessing various water quality parameters, and is one study that is based entirely in remote sensing due to the lack of in situ monitoring stations, which highlight the importance of this kind of orbital tools to monitor our water bodies. Our future perspectives, well, I have this map here which shows the rainfall erosivity projections for 2070, in which we see an increasing in the erosivity, which can be translated into higher amounts of sediments being put in the lagunal system and a higher rainfall. So this means that these extreme rainfall events will not only repeat, but have the potential to be even worse, both for the continental area and the coastal water bodies. So we propose to increase an in situ validation journeys on water quality parameters to improve the algorithm performances, all types of algorithms, not only for suspended particulate matter, which was our main subject of study, but also for chlorophyll and turbidity. And we also propose to conduct chlorophyll studies for regions vulnerable to possible harmful algal blooms, such as the Lagoa do Casamento or the Lagoon Estuary, and create a permanent monitoring system for water quality monitoring for the Guayba River and the Patos Lagoon. Here is the bibliography used to build this presentation. And that will be it. Thank you so much for your attention.
Thank you, Sergio. A wonderful talk. And now it's question time. You can turn on the mic and ask Sergio directly, or you can type on the chat. Alex.
Hello, Sergio. First of all, I apologize for getting a bit later to your presentation, but I got from the introduction, so I think I got most of the gist. My question, I have a few questions for you actually, but I will just ask one first, and then let's see what other questions the other people have. But one of them is why you were interested in looking at the plumes area. For example, if you want to know the amount of SPM in the lagoon, why not do an estimation of the SPM of the whole lagoon instead of focusing on the plumes? I missed a little bit the explanation for that.
Okay, we maybe I missed it for this particular presentation, but in our integral study, we intend not only to watch the concentration of sediment plumes for the concentration of suspended sediment or sediment load for the sediment plumes, but also for the entire lagoon. So we are working on it. But we prioritize for now the sediment plumes because of its, especially in the 2024 event, because of its very special characteristics that was not noticed never before this happened in the region. And maybe the implications, because if you can see in this slide, we had the highest um, concentrations of sediment, of suspended sediment, restricted to the sediment plumes. It was a total different mass of water entering into the system, and we wanted to understand how this might be affected, or how are the dynamics of these plumes entering into the lagoonal system. That is why we focused on that, but we are also going to perform what you are mentioning. Thank you, Alex.
Thank you, Sergio. And congratulations for the study.
Thanks.
Harriet?
Hey, Sergio. Thank you for that impressive talk and such an important topic as well. I was wondering how transferable these methodologies are for other regions, or maybe other parts of Brazil, or even in different situations where extreme rainfall events are becoming more concerning or more frequent. Yeah, how transferable the methodologies would be.
Well, our main algorithm that we used in this study, that was the multi-wavelength suspended particulate matter algorithm, is totally adaptable for the region that you wish, since you can calibrate the IOPs to better match your in situ data. So it can, and we are doing efforts to translate it to other regions of the world. I am actually going to perform uh, to try to perform a new analysis in an Amazonian estuary using this algorithm, due to its flexibility and the uncertainties that it can provide us, even when we don't have a lot of in situ data. Although we need some in situ data to calibrate it, it already provides you with some uncertainties in its measurements. So this methodology can be transferred to another regions of Brazil, and we are actually going to try to translate it to another regions of Brazil. Thank you, Harriet.
Okay, there's a question from Igor from IGBs in the chats. So do you think that with the extreme concentration of the Patot lagoons, are you still in the range of that extreme concentration still in the range of CR2 cc's? And did you try to use the Sentinel-2 with the C2X or C2X complex?
No, we actually didn't try it, Sentinel-2, at least for this particular study. We are assessing its performance for a wider analysis, a wider historical analysis for the lagoon, and especially for the Guaíba River, due to the higher resolution of Sentinel-2. And these extreme concentrations are still in the range in the C2RCC. Well, I don't know if particularly for this correction, it is still in the range. It was actually a challenge for us due to the very high concentration.
I think Sergio is breaking up. Harriet, you still with us, or is it my internet? Or
Yep, I think it's just Sergio. So
okay,
hopefully he
yep.
will come back to us in a second.
Uh, okay, I guess I lost my internet connection for a moment. Sorry. What was the last that you hear?
Maybe like 1 minute ago. Yeah,
Okay.
you were discussing C2 RCC.
Okay, I don't know for. I was telling that I don't know for this particular atmospheric correction since we didn't test it for this analysis, at least. Um, well, I don't know. No, it's not used in the Sentinel-2 level analysis rate products, at least for the neural network chlorophyll concentrations. It is not that. Atmospheric correction is not used. It is used another one also based in neural networks. But we didn't test it. But I can tell you that yes, these extreme concentrations of sediment, suspended sediment, gave us a lot of challenges. So we had to test various um, atmospheric corrections as well as algorithms, especially for the suspended particulate matter, which was our main goal in this research. And we even just to let you know, we had to use some adjust some filtering, like the saturation, which is normally for 50%, adjusted to 70%, so that not all the pixels inside the sediment plumes were filtered out from our images, and we could get some type of information. So yeah, they actually mess these extreme events mess up with the atmospheric correction, and we have to take care with the parameters that we use for that.
Sergio, Igor, did that answer the question?
Hi, sir. Thank you, Dwayne. So, Sergio, but you said that you use level 2 products for chlorophyll and KD, right?
Sorry, can you repeat, please?
You said that you use the level 2 products for chlorophyll A and KD.
Yes, for chlorophyll A, we use the level 2 products.
And the level 2 from BQ is using C2RCC, right?
I understand. If I'm making a mistake right now, please excuse me, but as I understand, the chlorophyll alpha concentrations at level 2 products has two chlorophyll alpha products. One that is for open waters that actually use the C2RCC atmospheric correction, and the neural network used for case 2 complex waters, which uses a different atmospheric correction, especially created for this case 2 waters. So, as I understand, this neural network product doesn't use C2RCC.
All right. Is there anyone have any more questions? If not, then we will come back to Alex.
Thank you,
There's
dude.
just one
Alex,
in the
yep.
chat. Oh yeah, there's this one in the chat as well from Darling.
Okay. Could I go through that question first, and then
Of course.
Alex will be next after that? So there is a question from Darling in the chat. Is our SPM method publicist? And then if that, then could you share that the link for that publicist method?
Yes, it is actually one of the bibliography that I shared here. It is this one. I can share you the DOI in the chat. Is this 2020 algorithm proposed by Tabora? Okay, I sent it to the chat right now. Please tell me if it works.
Yep. Okay. Alex?
Thanks, Dewey. Sergio, it's said that we have such a little time because there's many questions to ask, especially knowing more about your ambitions and perspectives, more in depth your thoughts on all this study and the future prospects for it. But I have a more focused question in terms again of your SPM. Your estimation of the mass, because when you say, for example, or maybe I misunderstood you, so it would be a good opportunity for you to explain, maybe when you say that the way that you integrated the amount of mass is that you use the KD and then you calculated the photic zone depth by assuming that the SPM is vertically uniform within a range. I guess you're not assuming for the full range. And that's my question is, because as the SPM increases, your penetration depth will decrease. So you're going to be integrating a lower depth. So is there a way to try to remove this effect? Because it almost gives the impression that the higher the SPM, then the lower the vertical integration that you're going to make, and therefore the lower the SPM you're going to be estimating. Or I misunderstood something. And is because you said that also the Patas Lagoon is quite shallow, and would be reasonable to assume that's vertically uniform through the whole vertical range, and then just do a multiplication by the bathymetry to get the volume of water. So do you think that this approach that you use where you do the KD, it's penalizing, let's say you're getting less mass because on the higher concentrations because the olfactic the KD reduces?
Yeah, we actually we struggled a lot deciding which depth were we going to use, or were we going to assume to be to represent the actual depth of the sediment plumes. As you mentioned, yeah, probably we are underestimating the amount of sediment load that was carried by the plumes. However, if you see here in this formula, I couldn't detail it because I have a limitation of time, but we had to restrict it to the bathymetry depth in many cases, and that is because the euphotic depth was sometimes even deeper than the actual bathymetry of the lagoon. So although we think that we are underestimating it, we may be underestimating it, it could be reasonable results. In many occasions, we saw that it reached the bathymetry. And for the study that we intend to publish, we are going to not only evaluate this case using the euphotic depth, but also we are going to evaluate vertical mixing of 1 meter, and you gave me now the idea of evaluating it also for using the bathymetry depth of the Patas Lagoon.
Yeah, it's because when is low concentration and you reach the bathymetry, then yeah, you're getting a much more vertical. And it's just like when it's super high concentration, you're not going to integrate all that column, and that may impact your estimation. The specific, so you're in the sense to say like the bias would be different for low concentrations and high concentrations. So, but it's good that you have other things in the pipeline that would address that as well. Thanks for the explaining.
Yeah, thank you, Alex, for the question, for your comments.
Thanks, Alex. We have one more question. Anyone? Okay, so I guess this is so. Thank you so much, Sergio. As
Thank you.
and congratulations on the talk. So the talk will be recorded and we will publish it on our YouTube channel. Um, I think you could find the link in the chat. And we also want to remind us the Water Talk series is one we will run it yearly. It means that we will have the next Water Talk series coming soon, and so we will announce that on the Geo AquaWatch website and or on any Geo AquaWatch social media. So that was out, and hopefully that you could secure a spot to present for the Water Talk next year. As well as we also welcome any Earth observation and remote sensing scientists